Hello, welcome to the third video. In this one, we'll take a closer look at on this schematic architectural plan and how we can put our panels onto this. Obviously, there will be several videos to apply the panels that we created in the first two videos onto this plan. But in this third video, we'll just try to extract the surfaces or the base curves for the panel creation based on their spaces or functions. So let's start with this one. So what I'll be doing, this was our panels, and don't worry, our panels are here somewhere. They are there to explain the logic, but this is our Rhino file for the plan. So what I'll be doing first is, these are the hatches based on the information and like the plot boundary, plan boundary. Plot is the purple area. Context buildings are this. It's an imaginary site, imaginary schematic plan. And what I can do is I can say cell hatch. I can select all the hatches and then lock them because I would need to put my curves in. And what I'll be doing first, I'll be taking my curve that is the plan boundary. Because what we are going to do is we are going to try to find the intersections between our curves, the planned curve, plan boundary, and the spaces. All right. And so what I'll be doing now is to put the other curves, and I'll grab a curve, and then I'll be defining these curves one by one just to make sure everything works. So admin rooms. Oh, this is admin offices. Let's say admin offices to this. The same logic. So admin offices. So admin offices is gonna be my first curve. Okay. And then you can type the admin offices on this. It's completely up to you. We don't need to put anything on the circulation. Okay. We can go with the conference room. Set one curve. I'll be going to alphabetic order. We'll need the entrance. Set one curve to the entrance. And then we'll go with the meeting room or meeting rooms. Set multiple curve. These are my meeting rooms. Okay. And the last but not least is what I'll be saying is open office is this. Open space, we don't need that, so we can select open office. So these are my curves, and if I can put the merge. Obviously, there are a lot of plugins where you can extract this information by calling them by their name. You can do that, and this is one of the ways to do that is the pipeline, geometry pipeline. So you can put the name, you can put the layer filter, name filter, points, curves. Like for instance, if I say just rename this, copy the name of it, right click to this, layer filter is going to be this, commit changes, and the name filter and the type is going to be curves. So you see it's basically grabbing the curves. So we can proceed with this as well if you want to, and maybe we can just proceed with this guy. Okay, and then copy this and the rename conference room, because this second thing that we are going to have is a conference room. Layer filter is conference room, commit changes, you see we have the conference room. Then we will going to have the entrance. Maybe I can just type entrance since it's one word. Entrance. And the other one is going to be meeting rooms. Oh, there's a problem with the text, but we are not relying on this text, so it can stay with the layer name. So we can say meeting room. And last but not least, we can say open office. mean, the good thing related to this is if you add, like, let's say, if you change one of these names. So if I change this curve to entrance, change object to layer, you see that entrance layer has now two curves. Okay, and it's directly put into here as well. Oops, not you. Okay, now I have 6 curves. You can merge them, you can entwine them, you can just graph them. Like, what we can do here is basically, if we have something like, if we have multiple curves here, that's okay, but let's leave them as they are for now. And what we are going to do is we are trying to grab the, like, sort of the idea of where we are going to place the panels, right? So if I just divide this length, or divide the distance. All right, what this does, what divide length does is, if I divide this into, like, let's say 2 meters, it will divide. Why I don't see the points? Oh, of course, it's not 2000 anymore, it's in meters. So what this does, it's basically each distance here that I'm seeing is 2 meters. All right. The length of the curves though, okay? Maybe this is important, so why I don't copy this below and copy the next here so that we know what is happening, okay? So set one curve, this time this guy, set another curve, and this guy. You may see sort of a slight difference even in the point organization, but what I mean is, if I bake these curves onto, like, let's say side layer, and if I bake these layers onto, again, the side layer, and if I preview everything off here, this is the divide length. So if I call out the distance in between these points, you see it's always 2 points. But when it comes to corners, again, we are lucky here. We are lucky here. Not sure if we are lucky here. We are lucky here as well. And when we have the divide distance, okay, we have the same issue here. So what we can do here, maybe not bake them and just extend them a bit further. And now if I bake this, and this is the divide distance. So you see now, if I grab the distances, it's going to take the distances and divide this curve based on the distances. So it's not the length of the curve, it's the distance between points, okay? Whereas if this was the case, now if I copy this, it's over here, and put this in, and then if I say bake over here, and then you see that, are we still too lucky? Maybe I can have a distance here. You see, now we have 1.9 meters because now it's only calling out the lengths, not the distances between points, okay? So it's completely up to you on what you want to proceed or how you want to proceed with, but let's go with the length, okay? If we divide the length, divide the length, set one curve, okay, and if we divide the length by 2, we are having these points. So, like, in order to make things a bit fruitful, what we can say is, okay, we can just scale all this in 1D from this point. Oops, scale 1D from this point to maybe just a little bit, so that, oh, but the hatches are not going there. So why don't we do something as such? Let's open up the edges as well and just scale this guy on 1D from this point and really tiny change on it, okay? And let's see now. Okay, we have the corners. This is something I wanted to have. That's why I just changed this. Everything has changed. Cell hatch, lock it in, and move on. Now you see we have some corners that we want to take care of, okay? And now each length is basically 2 meters. What we want to do on these parameters, on these points, we want to shatter this curve, right? Because these are going to be our panel bases. But how we are going to decide if these panels are inside of these curves or somehow in any of these curves, and if so, how we can deal with that. So if I go to my intersection under mathematical, or sorry, under physical, no, not this one, mathematical, maybe under surface and util points in curves in B wraps, curve in, sorry, point in curve and point in curves. So what we are going to do, we'll be using this guy. Sorry, I didn't mean to click on the layer in Rhino. It's nothing related with this one. And then what we'll be doing is, in the next video, we'll be taking these segments and try to find out if they are related to admin offices, open offices, meeting rooms, conference rooms, or entrances. So that's pretty much what we have done for this video. And in the next one, we'll proceed with the arrangement of the facade curve or base curves.